go ahead and take a similar approach to solving this bond yield to maturity problem. And by taking a similar approach, what I mean is beginning with this idea that there's a basic process that we like to use. So I'm going to suggest that you go ahead and pause your video and read this thing twice, and then we'll get back into it. So now let's go ahead and, just like last time, document our assumptions. And the information is largely the same as it was last time, but now we are being asked to solve for something a little bit different, because what we have now is information on pricing, whereby we don't have information on yields anymore. So what do we then know about this? There was a book value of $50 million. Let me move that down just to give myself a little more room. Make sure that we formatted that property. We're missing a zero. Okay. That each bond has a par value of $1,000, same as before. That there is a coupon rate, and that coupon rate is the same rate as last time, which is 4.75%. Again, I'm going to label that as being semi-annual. We know that because those payments are coming twice in June and December. Prices then are at 102. Now let's make a note. Whenever we say prices that are at 102, what we quote prices are quoted in percent of par. So if you say if something is 102, what you really mean is, in order to solve the bond price, you take the quote price. So in this case, that would be the 102 converted into decimals, and then you multiply that by the par value. So in our case, 1.02 would be 102%, multiplied by 1,000 would tell us that our price is $1,020. So if we wanted to, we can go ahead and do that calculation actually in here, which would be to take this. We need to convert it into decimals and then multiply it by the par, and there's how we got our 1,020. Again, if that was too quick for you, feel free to pause the video, rewind it, go back, watch it again. And we still then now need to know that right now, today is January 1st, 2016, and that this matures in 12/31/2025, and that they originally were issued back sometime in 2000. So now that I've got everything documented, again, for me it's very helpful to kind of draw this out and think about, okay, what would my life be like today as a bond investor? So as a bond investor, I'm looking at the following. I am willing to pay 102%, or $1,020 right now. That's a certainty for something then that promises me the following. Just like the last time, it would promise me a coupon payment, and then it would promise me another coupon payment, and it would promise me a bunch of coupon payments. How many? Just like last time, because we had a number of periods which were 10 years, but it's semi-annual. It's really 12 semi-annual periods. How much is that coupon payment? Again, we take that coupon rate, we multiply it by our par value, but because those payments come twice a year, we divide it by 2. We see that familiar $23.75. So I know that the coupon payments are $23.75. I know that I would also get this $1,000 par value. And that's a pretty terrible box. And I know that I have 20 semi-annual periods remaining. So the question is really one about what are the yields or rates of return for similar bonds. So again, let's use our standard 5 variables, where present value is price. That doesn't spell price at all. Either does that. We'll get there eventually. Future value would be par. Payment would be coupon payment. rate would be yield to maturity, and number of periods would be maturity. We know that we have 20 periods here. Actually, why don't we just point and click, since we typed those in already up there, so we're not repeating ourselves. We're trying to find the yield to maturity. We know our coupon payment is $23.79. We have a par of 1,000, where our price we know was $102. But remember, because this present value in Excel needs to be thought of in terms of investment terms, we need to put a negative sign in front of that so that our formula will work. And now let's go ahead and drop our rate in there with 20 semi-annual payments of $23.75, for which I paid $10.25 right now and would get $1,000 per year. We'll expand that out, $1,000 in the end. And what we get is a yield to maturity of 0.0225. But to get that problem correct on a test, you would have to show that that is the semi-annual rate. Or if you wanted to go ahead and annualize it, since that's semi-annual, if you multiply it by 2, expand it out, so we got 4 decimals here. And what we would see is that we would have an annual yield to maturity that's about 4.5%.